Okay, in this video we're going to talk about when two lines cut by a transversal are parallel. So, reviewing what we already know, we know that if, let's say we have two lines and they're cut by a transversal, we know that we call this angle and this angle, those are corresponding angles. I know that this angle and this angle are corresponding angles. I know that this angle and this angle are corresponding angles. And let's see, this and this, that's corresponding angle pair. So sometimes if the lines are coming, are intersecting the transversal at different angles, you get sometimes a big angle corresponding with a small angle. Here's a smaller angle corresponding with the bigger angle. It all depends on the angle of the lines as they intersect with the transversal. So what we're going to look at now is a special case, and that's when the lines that are cut by a transversal are parallel. Okay, so let's look at this. We have a drawing here where we have two lines cut by a transversal. The lines are parallel. Let's take a look. Angle 1 and angle 3 are corresponding angles. 2 and 4 are corresponding. 7 and 5, 8 and 6. And it turns out that all of the analysis of angles that result with parallel lines cut by transversal stems from this idea that, as it appears, corresponding angles are going to be congruent. So when the lines cut by a transversal are parallel, the corresponding angles will always be congruent to each other. For example, angle 1 will be exactly the same measure as angle 3. So this is a fundamental fact that we're going to use. When the lines cut by a transversal are parallel, so they must be parallel to get corresponding angles congruent. Then we use what we know about linear pairs and vertical angles to help us figure out all the other angle pairs. So it turns out that those angle pairs called alternate interior angles are also congruent. Let's see. If angle 1 is congruent to angle 3, and we also know that angle 1 and angle 7 are congruent vertical angles, so naturally it follows that angle 3 and angle 7 are congruent. Similarly, let's see. We know that angle 2 and angle 4 are congruent corresponding angles. 2 and 4 are congruent corresponding angles. Well, I also know that angle 4 is congruent to angle 6 because they're vertical angles. So it follows that angle 2 is congruent to angle 6. So if the lines cut by the transversal are parallel, the alternate interior angles are congruent. Similarly, the alternate exterior angles, let's go to those next. Let's hop down to alternate exterior angles. Let's see. It turns out that angle 1 and angle 5 are congruent, and angle 4 and angle 8 are congruent. They look congruent, and they are. We can use the same idea. We can say angle 1 and angle 3 must be congruent because they're corresponding angles, which are always congruent when the lines are parallel. And look, angle 3 and angle 5 form linear vertical angles. So if 1 is congruent to 3 and 3 is congruent to 5, then 1 must be congruent to 5. Alternate exterior angles are congruent. The next one to look at are consecutive interior angles. So look at the figure. The lines are parallel, cut by the transversal. Do they appear to be congruent? Well, let's see. Angle 2 looks kind of acute. And angle 3 looks kind of obtuse. Well, it turns out that they are not congruent, but they are supplementary. So consecutive interior angles are supplementary. So they will sum to 180, and we can prove that with our knowledge of linear pairs and congruent corresponding angles. And similarly, let's look at some what you might call consecutive exterior angles. Let's look at like 8 and 5. We're using the word consecutive exterior angles. In this case is describing exterior angles that are on the same side of the transversal. They're definitely not congruent. 8 is congruent to 6. 6 is supplementary with 5. So 8 is supplementary with 5. So consecutive exterior angles are supplementary. So the ones that have the word consecutive in them are supplementary, and the ones that have alternate in them are congruent. Supplementary. And the bottom line is, the easy part of this is, if the lines are parallel, it's pretty clear that the angles that appear to be congruent are congruent. And the angles that don't appear to be congruent are actually supplementary. Let me bring this up a little bit. Okay, so it looks like we're going to have two sets of congruent angles. One of them is going to be related to corresponding angles and their vertical angle pairs. So we've got the big ones, 1, 3, 7, and 5. So we've got angle 1, angle 3, angle 7, angle 5 are going to be congruent. And so there's a whole bunch of what appear to be obtuse angles. And let's see, let's try the acute ones. Angle 2, angle 4, and their vertical angle pairs. Okay, so we've got angle 2, angle 4, angle 6, and angle 8. Bottom line is the ones that appear to be congruent are congruent.